So we're going to look at some database stuff tonight. The database actually should have the YouTube. The database I'm using is MySQL. That's a pretty popular one. These are in the wrong place. I just noticed. They should be up with the prior lecture. But we're going to look at some database stuff, and then just to see, and then we're going to try some Java stuff next week. Should be a fairly short lecture, and the database I'm using is MySQL. The product that I actually download that I use for a lot of the stuff is something called XAMPP. It's a pretty nice thing. It's free. You can download it. It includes Apache, MySQL, which is actually running, I can see. Something called FileZilla, which is an FTP process. Mercury, which is for email, right, doing your own email server. And Tomcat, which is for Java web pages. So XAMPP's a really nice tool. It's actually, I would say, in addition to NetBeans, it's probably about all you need to do any sort of web development with Java or PHP and MySQL. So it's a really nice tool. Those of you interested in trying it, it's free. Just do a search on XAMPP. Okay, so that means I should be able to get into MySQL since it started. And MySQL generally runs from the command prompt, although there is a GUI tool for MySQL, but I don't think I have it installed. But there is a GUI tool that's pretty good. Let's see if I've got it. Don't think I do, but yeah, I don't see it. Yeah, but there's a GUI tool, but you can also get it from the command prompt, which is actually how I'm going to do it. Okay, so that's basically the default. You see this MySQL prompt, and you just go in that way. Okay, so we're going to talk about databases, specifically the MySQL database and some basic SQL. There is a full semester course on MySQL that normally runs in the spring, and I normally teach it. There's going to be an alternate database class taught this spring. I'm not exactly sure what it's going to be, but there will be an alternative one. We're just going to cover SQL and MySQL. I'm not going to get into ADO.NET or JavaDB. I'm not going to cover that at all. This is really a precursor for doing some database and Java stuff next week. Some quotes from famous people, I guess. So we'll talk about what a database is and some of the relational concepts, and we're really just going to go very quickly over it. Talk about some basic SQL. There's a lot more to a database than you can learn in one night, but we're going to cover enough just to do some simple Java web stuff that connects to a database, and that's about it. And again, we'll talk about what a relational database is, give you kind of a quickie on what a relational database is, and the command that you'll use the most called the select command, but there's also important commands for inserting data, updating data, and deleting data. We'll talk about the MySQL database, obviously, and talk about installing MySQL. This isn't too applicable if you get the XAMPP tool, because XAMPP actually does it its own way, and it does it automatically. It's actually an easier install with XAMPP. So, again, it's something I definitely would recommend. A database is a collection of something called tables, and if you think of when we were doing two-dimensional arrays, you can think of a table as being like a two-dimensional array, or like an Excel spreadsheet in Excel. The exception being is that it's stored on disk. So a database provides permanent storage for these tabular type data structures, whether it's an array or an Excel file or something like that. And it's going to show you a couple of examples there. One is a table that we're going to say that we're going to use to store all of our employee data in, and it looks like this. And you can imagine this could look like a spreadsheet. It is number, name, department, salary, and then what we'll notice is that the number would be the employee number. It would also be something called a primary key. Primary key in database terms is a value that uniquely identifies a row in a table. So you can think of Excel has numbers. They range numerically in order from 1 through whatever. If you look at an Excel spreadsheet, right, it's got a number on the left side. That's sort of what that is. You'll never see the number 10 twice in Excel. If you bring up Excel, you would never see the number 2 twice. And let's see, I actually don't have Excel. I have OpenOffice, but they have something called Calc, which is basically the same thing. We'll bring that up. Okay, at some point it'll come up. Before it can start. That's unusual. I actually do have Excel, but I don't have the actual license for it. It should let me open it. And it's going to give me something about buying it. Oh, here we go. Finally, it came up. This one here is Excel, and the one behind it is OpenOffice. So you'll notice you've got a number to the sides, 1 through whatever, and it's numeric, and it doesn't repeat. And that's basically Excel's primary key, if you will, for it, meaning that just a number that uniquely identifies that row. And if you think of yourself, what would be your primary key? Well, for most of you, that would be your Social Security number. That uniquely identifies you. So that your Social Security number would uniquely identify you. Okay, we'll leave it there for now. So this is an example of a table. Store all your employees, and you might even think that if you were running a small business, that's what I don't like. Get lost. Yes. Okay. You might think, well, if you were running a small business, or I'm sure many people have done this either for business or personal stuff, created a little spreadsheet, and maybe it was for the contacts for your friends. You might put their name, their phone number, their email in different columns in Excel, and each row would be a new friend that you might keep in there, or your record collection. Well, I guess not too many people have record collections anymore, but any sort of thing you might have. So that's basically what that is. And this is another example. This is a smaller table called the department table. If we go back, we see that we have a department number in this table. Now, we don't have all the department details. We just have the number. So we can find the department details over here. So you might ask yourself, well, why not just put them all in one Excel file? Not just the department number, but also the location. Well, that gets confusing, because the problem is you probably have more information than just a name or a location of department. You may have a dozen different data fields about that department, and if you include all the data in one worksheet, it becomes unmanageably large. You wouldn't be able to do it. And in terms of database, we call this denormalized data, which is considered a bad thing. It's a bad thing because if we had all the information about department in here, and we have department 413 twice, then all the information, the name, the fax number, the location, the manager, all that stuff will be duplicated at least 3 times. And if we needed to make a change, maybe they got a new manager, and we would have to update this table 3 times. Well, most of the time it's going to be even more than 3 times. So you'd have to update it, a whole bunch of times. And what if you missed one of the places where you needed to update it? If that happened, then you would have what's known as an update anomaly, which means you've got a discrepancy between data. And then people will start to not trust the data, because in one place it says one thing, and another it says something else. So the way we avoid these issues, these data issues, is that we do something called normalization, which means that we take every piece of logical information and put it in its own table. So much like we say in the case of objects, you might create an employee class, but you probably wouldn't put all the employee information in there. All the department information in there. That employee class would be just everything about the employee, and it wouldn't have another object, a department being another object. It would be just the information about that employee, right? And a table is essentially the same thing. There's a relationship between a database table and a class. A lot of times it's a one-for-one relationship, as we'll see. Whereas you've got the data in the class, but how do you persist it so that the next time you come back it's still there? Well, normally we map objects to database tables. Is how we do it. And we'll see more about that next week when we get into more of the Java end of databases. Okay, so here's another example. It's giving you some ideas. In this case, it's using something called an authors table, which is going to have an author ID. And usually the first column in every database table is a ID, something ID. And it's a unique numeric value. Just like you have a unique numeric value on Excel on the left. And then you have the data elements, like name, for example. And this shows you some information that you have on this particular person. It's another table. It's creating a table of authors and ISBNs and books and how it works. And this one here is the actual titles table. I think I've probably got all these tables. I'm not mistaken, or maybe not. Yeah, I do. Yes, let's see what would the other table is. So this is the books table. Okay. Doesn't exist. It's author ISBN. And there's some data. And if we were to do like a select from titles, we're going to get into these commands a little more. There's all the data. Okay. Not providing value for every column in a primary key breaks the rule of integrity. I wouldn't worry too much about this. In general, primary keys, the standard is that you have the database create that key for you. And we'll see how to do that in a moment. Providing the same value for primary key. Now, primary key's got to be unique. So if you try and give two people the same social security number, it's not going to work. They have to be unique. That's a rule about primary keys. This shows you the relationship what we have. And go over it a little bit. Titles would be like essentially a book, and then you have a table for authors. And then we have something in here called author ISBN. And this represents what we would call typically a many-to-many relationship, meaning that an author can author many books. An author usually will write more than one book. And a book or a title can have multiple authors. So we would say authors and books have a many-to-many relationship. Author has many books, books has many authors. The way we normally handle relationships is that the primary key of what we would call the parent is stored as a column in the child table, and in the child table it's called a foreign key. That works when you've got one parent and one child. One parent meaning there's a one relationship to many. So if authors only wrote one book, or if books could only have one author, we would be okay with drawing a line directly from authors to title. The problem is we can't. So this is almost like a husband-wife situation, right? Mother-father situation. Where we need, in this case, we have two parents, authors and titles, to make one child, author ISBN. And this is generally referred to as an intersection table, meaning that it allows, or this is how we would create something called a many-to-many relationship, or a bridge table, or an intersection table sometimes called. But the table that's got the one is always the parent. The table that's got the many, and that's very often represented by this infinity sign or a sideways number 8, is the many. And providing a foreign key that does not appear as a primary key value in another table breaks the rule of referential integrity. So what this basically means is that every child has to have a parent. No orphans allowed. So going back to this model, imagine we had ISBN in here 1, 2, 3, 4, 5. But when we look at the books, we don't see an ISBN of 1, 2, 3, 4, 5, 6. So we're saying that this child has a parent that doesn't exist. In the database world, that's not allowed. It's called the no orphans rule, or referential integrity. And the reason being is that the data in this child is essentially useless if you have no way of linking it back to the data that really matters, or that's really important. You have it's basically useless, so you shouldn't have it. It's a waste of disk space. Providing a foreign key that does not appear, okay, primary key, so this is what we talked about. The rule of referential integrity. So a child has to have a parent. Okay, any questions on this so far? I'm going to get to some